Okay, in this lesson, we're going to be talking about functions. Okay, function is defined as a relation in which every member of the domain is paired with exactly one member of the range. Okay, what does that mean? So let's write this out. Function is a relation in which every member of the domain is paired with exactly one member of the range. Okay, think about that definition for a minute. Function is a relation. We talked about relation in our last lesson. And a relation is a group of ordered pairs, right? X comma Y are coordinates 1 comma 2, 2 comma 3, 0 comma 1. That is a relation, okay? So a function is a relation in which every member of the domain, okay, so all x values is paired with exactly one member of the range. So in other words, 1 comma 2 and 1 comma 3 is not a function, okay? Because we have, here's the domain, right? This is the domain right here. And then, let me just write the arrow. Domain. Domains are your x values, okay? And then we have your range. Which are your y values, okay? Every member of the domain, right? So the x value is paired with exactly one member of the range. Well, in this case, you have two members of the domain. You have one member, sorry, you have one member of the domain paired with two members of the range, okay? So that's not a function. Another way to look at this is if we have 1 comma 2, okay, and 2 comma 2, this is a function, okay? That first combination is not a function, okay? So I'm defining a function for you so far in two different ways. The first way is via words, right? Right here, function, function. So if those words don't make any sense to you, then I'm also defining it in terms of relations, right? The combination of x and y values or coordinates. Okay? So in this case, this set right here, 1 comma 2, 1 comma 3 is not a function. However, 1 comma 2 and 2 comma 2 are a function. Okay? If that doesn't make any sense, then there's a third way for you to understand this, and it's in graphical form. Okay, so let's suppose we have a graph like this. Okay, and this is your y-axis, x-axis, and let's say we have a line like this. Okay, there's a test called the vertical line test, and that vertical line test says as long as I draw a vertical line and it crosses the function, in this case it's represented by blue, okay, I'm going to write this as f of x. I'll explain that notation in a minute. F of x is a function. As long as you draw a vertical line through any part of the function and it only crosses it at one point, then it's a function. Okay? Let's suppose we have another graph. Okay? This time we have a function that looks like this. Okay? This is a function. In Algebra 2 or in advanced algebra, you will learn this particular function. It's called the parabola, but you don't need to know that right now. In this case, if I do the vertical line test, okay, anywhere along the function, you will notice that I cross the function at this location right here and at this location right here. Because the vertical line crossed the function more than once, this is not a function. Okay? So those are three ways to define a function. Note that these 2 points, let's suppose on the graph on the right, let's suppose that this was at 1 and then this is 2, okay? And this is at 1, 2, 3, 4. And let's say that's 4, okay? Then the vertical line test crosses the function at those 2 red circles. And those coordinates are 2, 1, okay? And 2, 4. You see how there is one domain right here, one domain to 2 ranges, okay? 2 members of the range. Remember in the previous example how we said this is not a function? See how the x's are the same and the y's are different? That's not a function. We have the same thing here. The x's are the same and we have different y's. This is why it's not a function. Okay? The easiest way to determine if a function is a function or a graph is a function, in my opinion, is to use the vertical line test. Okay? If it crosses that function only once, then it is a function. If it crosses that function more than once, then it is not a function. Okay? Okay, so let's move on to the notation that I mentioned. Okay, we have f of x, let's say, is equal to 15x. So the way to read this is the function of x. Okay, so this is called function of x, or You could say f of x, okay? This is the equivalent of saying, I'm going to just draw it over here to the right. This is the equivalent of saying y equals 15x, okay? But we're replacing y with the notation f of x, okay? The reason that we're doing that is because they're trying to describe for all value of x in this function, what is the value of y? Okay, so let's say, for example, the problem says find f of negative 3 if f of x is equal to 15x, just like the problem above. All they're saying is take the value of negative 3 as your x and plug it into the equation, okay? So in other words, f of x is equal to 15 times negative 3, okay? Let me just erase this and highlight that in green, okay? Find f of negative 3. So we plug that in. And I should probably do this too. So that I write this correctly, okay? So f of negative 3 is equal to 15 times negative 3. And therefore, f of negative 3 is equal to negative 45, okay? So what we have here is we have a coordinate, right? Whenever you put in an x for negative 3, negative 3, it's y, y equivalent is negative 45, okay? Right? Because we've plugged in negative 3 for x, so that goes into the domain right here. Domain. Okay? We plugged that in and we got the function of negative 3 to be negative 45. So this becomes our range. Okay? And remember I said that this notation right here is equivalent to y. And since y is equal to negative 45, this is why we put the negative 45 over there. Okay, I just threw a lot of stuff at you. There's a lot of things going on, but here are the key things to remember. Okay, key things. Function must pass vertical line test. Okay, vertical line test. So the vertical line has to cross the path, the graph at no more than one place. If it crosses it twice, it's not a function. Okay. Number 2, this is called a function. And f of x is the same thing as calling it y, okay, or some other variable. Y is usually the default variable, okay? And then this value becomes your x coordinate, and then this becomes your y coordinate, or domain in range. Okay, so let's just walk through an example just to kind of solidify your understanding here. Let's say we have a function f of x is equal to x minus 7. Okay? What we can do is throw in all sorts of values of x. In other words, x this is x minus 7, okay? And then this is my f of x, or in this case, y. So we're going to throw in just for the sake of argument, -2, -1, 0, 1, and 2. Okay, we're going to keep this simple. And we're going to calculate this. So this becomes -2 minus 7, -1 minus 7, 0 minus 7, 1 minus 7, 2 minus 7. Okay? We put in the x values into this equation. And what we get for f of x is -9, -8, -7, -6, -5. Okay? So this function will look like this. When you graph it. Okay, so I'm going to rewrite the coordinates here. We have our x's on the left and our y's on the right. So our coordinates will be as such. Oops. So we're going to do 5 points. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so first coordinate, I'm going to just write all these out. 0, 1, 2, -9, -8, -7, -6, -5. Okay, I'm color coding this so you know which ones are x's, which ones are y's. Okay, so now I'm going to put my hash marks. 2, 4, 6. 2, 4, 6. 2, 4, 6, 8, 10. Okay, so my first coordinate right here, -2, -9. So I'm going to go -2. Okay, so we're going to go to the -2 on the x-axis, which is right here. Right here. Okay, and then we're going to go down to -9. Okay, so we're going to plot our first point right here. We'll use the color, and we'll just use the color black. Okay. Then the next point is we're going to go to -1. Again, -1 right here on the x, and we're going to go down to 8, -8 on the y. That's right there. So we'll put a point there. Okay. The next point is right here, 0, -7. We're going to be 0 on the x. We don't need to move. And then we're going to just go all the way down to -7 on the axis. And we're going to put a dot right there. Okay. And you'll see the pattern. So the next one will be 1, 6, 1, -6. So that should be right about here. And then the last one is 2, -5, which should be right about here. Okay, so then my function or my graph would look like a straight line like this. Okay. So another term that I need to share with you are independent and dependent variables. Okay. So this right here on the top left here, these are dependent and these are independent. Okay, this is called independent because x could be any value. It's not dependent on anything, but the value of the y, or f of x, is dependent upon the input, or the x values. Okay, so let's review some of these terms just so that you keep things straight. Okay, we have domain, range. We also have x, comma, y as your coordinate. Okay, we also have independent, and then dependent. Okay, I'm writing these all in order because everything in the blue all represent x values, domains, independence. They're all the same thing, same terminology. And everything in the green, okay, are your range, your y's, your dependent variables. Okay, all of these words are just different ways to express the exact same thing. The reason they're different words is because it depends on the context of how it's being used. Okay, and I guess I missed one other thing. This is also x, comma, f of x. Okay, so these are all included. I should extend this down. Okay, domain, range, x, comma, y, independent, dependent, x, comma, f of x. They're all exactly the same. Okay, depending on which side you're on. Okay, I threw a lot of stuff at you. This might have been a little confusing. If it's not clear, again, please go back to the beginning and listen to this lesson again and make sure you completely understand this. Okay, thank you.